Vogtle Electric Generating Plant. The Alvin W. Vogtle Electric Generating Plant, also known as Plant Vogtle, is a 2-unit nuclear power plant located in Burke County, near Waynesboro, Georgia, in the southeastern United States. It is named after a former Alabama Power and Southern Company Board chairman, Alvin Vogtle. Each unit has a Westinghouse pressurized water reactor (PWR) with a General Electric steam turbine and electric generator. Units 1 and 2 were completed in 1987 and 1989, respectively. Each unit has a gross electricity generation capacity of 1215 MW, for a combined capacity of 2430 MW. The twin natural draft cooling towers are 548 ft 167 m tall and provide cooling to the plant's main condensers. 4 smaller mechanical draft cooling towers provide nuclear service cooling water NSCW to safety and auxiliary non-safety components, as well as remove the decay heat from the reactor when the plant is offline. 1 natural draft tower and 2 NSCW towers serve each unit. In 2009, the Nuclear Regulatory Commission (NRC) renewed the licenses for both units for an additional 20 years to 1/16/2047 for Unit 1 and 2/9/2049 for Unit 2. During the construction of Vogtle's first 2 units, capital investment required jumped from an estimated $660 million to $8.87 billion. $16.02 billion in 2019 dollars. 2 additional units utilizing Westinghouse upon 1,000 reactors are under construction. Natural draft type cooling towers were also selected, and the 2 new cooling towers are nearly 600 ft 180 m tall. The units have suffered several delays and cost overruns. The certified construction and capital costs for these 2 new units were originally $14 billion according to the 17th Semi-Annual Vogtle Construction Monitoring Report in 2017. This last report blames the latest increase of costs on the contractor not completing work as scheduled. Another complicating factor in the construction process is the bankruptcy of Westinghouse in 2017. In 2018, costs were estimated to be about $25 billion. Upon completion of Units 3 and 4 in 2021, Vogtle will become the largest nuclear power station in the United States. Reactor Data. The Vogtle Electric Generating Plant has 2 operational reactors with 2 additional units under construction. Power uprate. In 2008, both reactors were increased in power by 1.7% by an Appendix K uprate, also called a Measurement Uncertainty Recapture (MER) uprate. Measurement Uncertainty Recapture power uprates are less than 2% and are achieved by implementing enhanced techniques for calculating reactor power. This involves the use of state-of-the-art feed water flow measurement devices to more precisely measure feed water flow, which is used to calculate reactor power. More precise measurements reduce the degree of uncertainty in the power level, which is used by analysts to predict the ability of the reactor to be safely shut down under postulated accident conditions. Because the reactor power can now be calculated with much greater accuracy than with the old Venturi-type measurement, the plant can safely run within a tighter margin of error to its limits. The new flow meter works by comparing the time it takes ultrasonic sound pulses to travel upstream versus downstream inside the pipe, and uses the time differential to figure the flow rate of the water in the pipe. The NRC approved Vogtle's license amendment request LAR in March 2008. The NRC staff determined that Southern Nuclear could safely increase the reactor's power output primarily through more accurate means of measuring feed water flow. NRC staff also reviewed Southern Nuclear's evaluations showing that the plant's design can handle the increased power level. Unit 1 was uprated during its spring 2008 refueling outage, and Unit 2 was uprated in the fall outage of the same year. Incidents and accidents. Loss of power. A loss of electrical power in the plant occurred on March 20, 1990. At 9:20 a.m., A truck carrying fuel and lubricants in the plant's 230 kV switchyard backed into a support column for the feeder line supplying power to the Unit 1, a reserve auxiliary transformer RAT. At the time, the 1B RAT was de-energized for maintenance, and RAT-1 was powering both trains of emergency electrical power. The non-emergency electrical trains were being powered by backfeeding from the switchyard through the main step-up transformer to the 1 and 1B unit auxiliary transformers UAT. Additionally, emergency diesel generator EDG-1B was out of service for planned maintenance. After the power loss, EDG-1 failed to start due to a protective safety trip. The resulting loss of electrical power in the plant's vital circuits shut down the residual heat removal RHR pump. Even though Unit 1 was offline at the time, residual heat from the natural decay of the radioactive fuel must be removed to prevent a dangerous rise in core temperature. While the non-safety power was not interrupted, there was no physical connection between the vital and non-vital electrical trains, preventing the vital trains from receiving power from the unaffected path through the UAT. At 9:40 a.m., the plant operators declared a site area emergency SAE per existing procedures, which called for an SAE whenever vital power is lost for more than 15 minutes. At 9:56 a.m., after trying multiple times to start the 1 EDG normally, plant operators performed an emergency startup of the EDG by activating the generator's emergency start brake glass, which bypassed most of the EDG safeties and forced it to start. The startup was successful. RHR was then started using power from EDG-A. With core cooling restored, the SAE was downgraded to an alert at 10:15 a.m. At 11:40 a.m., crews energized RAT-1B, which had been shut down for maintenance, restoring power to the B safety electrical train. At 12:57 p.m., the safety train was switched from the EDG to RAT-1B and the EDG was shut down. With both trains receiving off-site power, the alert was terminated at 1:47 p.m. The temperature of the Unit 1 core coolant increased from 90 deg F32 deg C to 136 deg F58 deg C during the 36 minutes required to re-energize the aside bus. Throughout the event, non-vital power was continuously available to Unit 1 from off-site sources. However, the Vogtle electrical system was not designed to permit easy interconnection of the Unit 1 vital buses to non-vital power or the Unit 2 electrical buses. Since this incident, Plant Vogtle has implemented changes to the plant that allow the non-vital electrical buses to transfer power to the vital buses in this type of scenario. This electrical fault also affected Unit 2 by causing breakers in the 230 kV switchyard to trip, cutting off power to RAT-2B and Vital Bus B. EDG-2B subsequently started and restored power to the Vital Bus. At the same time, the electrical disturbance from the falling line striking the ground was detected by protective safeties on the Unit 2 main step-up transformer and a protective relay actuated, opening the transformer's output breaker. This caused a full load rejection to Unit 2, leading to a turbine trip and subsequently a reactor scram. After Unit 2 tripped, the B non-vital electrical train lost power as it attempted to transfer from UAT-2B powered by the turbine generator to the failed RAT-2B, causing two of the reactor coolant pumps and one of the main feed water pumps to trip. Despite this, plant cool down proceeded safely. At 9:03 p.m., the RAT-2B breakers in the switchyard were reset and off-site power was restored to the vital and non-vital B electrical trains, allowing reactor coolant pumps 2 and 4 to be restarted. EDG-2B was shut down. It was later determined that the fault disturbance caused by the line falling was not of significant magnitude to trip the protective relay per design and should not have caused Unit 2 to shut down. Further investigation found that current transformers on the main transformer were improperly set. The controls were adjusted to the proper setting. Had the CT been properly set initially, the Unit 2 would have remained online. Units 3 and 4. Planning phase. On August 15, 2006, Southern Nuclear formally applied for an early site permit ESB for 2 additional units. The ESB determined whether the site was appropriate for additional reactors, and this process is separate from the combined construction and operating license COL application process. On March 31, 2008, Southern Nuclear announced that it had submitted an application for a COL, a process which would take at least 3 to 4 years. On April 9, 2008, Georgia Power Company reached a contract agreement for 2 Apone 1000 reactors designed by Westinghouse, owned by Toshiba. Westinghouse partnered with the Shaw Group Baton Rouge, Land, Stone, and Webster Division to manage the project, with Westinghouse responsible for engineering, design, and overall management, and Shaw responsible for manufacturing the prefabricated component modules and managing the on-site construction. The contract represented the first agreement for new nuclear development in the United States since the 3 Mile Island accident in 1979, and it received approval from the Georgia Public Service Commission on March 17, 2009. Construction. On August 26, 2009, the Nuclear Regulatory Commission (NRC) issued an early site permit and a limited work authorization. Limited construction at the new reactor sites began, with Unit 3 then expected to be operational in 2016, followed by Unit 4 in 2017, pending final issuance of the combined construction and operating license by the NRC. These dates have since slipped to 2021 and 2022 for Units 3 and 4, respectively. On February 16, 2010, President Barack Obama announced $8.33 billion in federal loan guarantees toward the construction cost, although as of December 2013, Georgia Power had not availed itself of those guarantees, at first awaiting the construction license, and after the construction stop lawsuit outcome. The expected building cost for the 2 reactors was $14 billion. Georgia Power's share was around $6.01 billion, while remaining ownership of the 2 reactors is split among Oglethorpe Power Corp., the Municipal Electric Authority of Georgia Meat Power, and Dalton Utilities. In February 2012, the NRC approved the construction license of the 2 proposed Apone 1000 reactors at Vogtle. NRC Chairman Gregory Jaczko cast the lone dissenting vote on plans to build and operate the 2 new nuclear power reactors, citing safety concerns stemming from Japan's 2011 Fukushima nuclear disaster, saying, "I cannot support issuing this license as if Fukushima never happened." 1 week after Southern Company received the license to begin construction, many environmental and anti-nuclear groups sued to stop the expansion project, claiming public safety and environmental problems since Japan's Fukushima Daiichi nuclear reactor accident have not been taken into account. On July 11, 2012, the lawsuit was rejected by the Washington, D.C. Circuit Court of Appeals. In February 2013, the project's construction contractor, Shaw, was purchased by Chicago Bridge and Iron Company CB&I. On March 12, 2013, construction on Unit 3 officially began with the pour of the basement concrete for the nuclear island. This operation was completed on March 14. During the weekend of June 1, 2013, assembly of the containment vessel began, with the bottom head of the vessel being lifted into place on the nuclear island. By June 2013, the construction schedule had been extended by at least 14 months. On November 21, 2013, the basement pour for Unit 4 was completed. In February 2014, the Department of Energy approved a $6.05 billion loan guarantee for Southern Company subsidiary Georgia Power and Oglethorpe Power Corp. The Department of Energy initially demanded a credit subsidy fee, but the demand was ultimately dropped given the financial strength of Southern Company. Further delays and cost increases were incorporated in a revised schedule in early 2015. As a result of the increased delays and cost overruns, Contractor CB&I exited the project, and Westinghouse took direct control of the project as contractor and hired construction firm Fluor to replace CB&I/Shaw on-site, managing the day-to-day work. Westinghouse purchased certain assets of the former Shaw Group from CB&I to allow the project to go forward. In 2016, Southern Company and Westinghouse added construction firm Bechtel to the project to share construction management responsibilities. Recent construction milestones include setting the final of the Big 6 structural modules for Unit 3 C-2 and C-3, which form the walls of a storage tank that is part of the reactor's passive cooling system. The Big 6 modules also include the previously installed C-1, C-4, and C-5 in containment structural modules, as well as the previously installed C-20 structural module, which forms part of the internal structure of the auxiliary building, containing many of the reactor's support systems. C-2 and C-3 were placed within the containment vessel in May 2016. The setting of these modules is a fairly significant milestone and allows other construction activities to commence. In June 2016, the final reactor coolant pump for Unit 3 was received on site. In November 2016, the reactor vessel for Unit 3 was set within the nuclear island. 2017 progress includes the installation of the reactor coolant loop piping and both steam generators at Unit 3. Progress has also been made in the turbine, auxiliary, and annex building. Unit 4 has also seen progress with the installation of the final two Big 6 structural modules. Construction of both cooling towers is complete, with each nearly 600 ft 180 m tall. Westinghouse Bankruptcy 2017. In March 2017, Westinghouse Electric Company filed for Chapter 11 bankruptcy due to losses from its two U.S. nuclear construction projects. The U.S. government has given $8.03 billion of loan guarantees to help finance construction of the Vogtle reactors, and a way forward to completing the plant has been agreed upon. On July 31, 2017, Southern Company Division, Southern Nuclear, officially took over construction from Westinghouse and opened a bid for a new construction management contract to manage the day-to-day work on the site. Southern received bids from both Fluor and Bechtel. On August 31, 2017, Southern announced its decision to move forward with Bechtel to be the day-to-day construction manager for the remainder of the project. Bechtel will replace Fluor, who will no longer be involved in the project. Continuation of construction approved 2017. In November 2017, the Georgia Public Service Commission (GPSC) requested additional documentation following concerns that design blueprints had not been approved by appropriately licensed engineers, which has legal implications. On December 21, 2017, the PSC approved the continuation of construction on Units 3 and 4, with conditions that reduced the costs that can be recovered from ratepayers over the life of the project. In the February 2018 Vogtle Construction Monitoring Report (VCM), GPSC approved November 2021 and November 2022 as the target in-service dates for Units 3 and 4 respectively. The report notes that the project is being completed on an accelerated schedule and is currently tracking ahead of the 2021 and 2022 in-service target dates. In August 2018, a $2.03 billion increase in costs was recognized. The total cost, including financing costs, is estimated at about $25 billion. In September 2018, in order to sustain the project, Georgia Power agreed to pay an additional proportion of the costs of the smaller project partners if the cost of completion went beyond $9.02 billion. In March 2019, further federal loan guarantees of $3.07 billion were given to the various build partners. The Georgia Power CEO said the loan guarantees played a key role in reducing financing costs for the build. Also in March 2019, Georgia Power confirmed that the Unit 3 containment cap had been lowered into place and the reactor would be ready to load nuclear fuel in 2020. This was preceded by the containment vessel third ring, as well as reactor coolant pump and polar crane installation in Unit 3 during 2018 and 2019. The containment vessel top head was set during a site visit by Secretary of Energy Rick Perry and executives of the plant's owners. Recent progress on Unit 4 includes the installation of the final steam generator and pressurizer. Unit 4 is being constructed utilizing lessons learned from Unit 3 and from the failed Vogtle C Summer Nuclear Generating Station VC Summer project, and as a result, the order in which some components are being installed has been modified. On November 22, 2019, the third ring of the containment vessel was set for Unit 4, and on December 8, 2019, the Unit 3 shield building roof was set above the Unit 3 containment vessel. On December 16, 2019, the control room of Unit 3 became operational and is now available for testing systems. On February 11, 2020, Southern Nuclear announced that the final concrete placement inside the Unit 3 containment vessel was completed, which will allow installation of the reactor's fueling machine. As of February 2020, assembly continues on the final top most vertical feature of the overall unit. Surrounding population. The Nuclear Regulatory Commission defines two emergency planning zones around nuclear power plants: a plume exposure pathway zone with a radius of 10 miles 16 km, concerned primarily with exposure to and inhalation of airborne radioactive contamination, and an ingestion pathway zone of about 50 miles 80 km concerned primarily the 2010 U.S. population within 10 miles 16 km of Vogtle was 5,845. The 2010 U.S. population within 50 miles 80 km was 726,640, an increase of 8.8% since 2000. Cities within 50 miles 80 km include Augusta, GA 26 miles 42 km to city center. Seismic risk. The Nuclear Regulatory Commission's estimate of the risk each year of an earthquake intense enough to cause core damage to either reactor at Vogtle was 1 in 140,845, according to an NRC study published in August 2010.